Hello students, let us continue the next point. Limitations of mean deviation. In a series where the degree of variability is very high, the median is not a representative central tendency. Thus, the mean deviation about median calculated for such a series cannot be fully relied. The sum of the deviations from the mean is more than the sum of the deviations from the median. Therefore, the mean deviation about the mean is not very scientific. Thus, in many cases, mean deviation may give unsatisfactory results. Also, mean deviation is calculated on the basis of absolute values of the deviations and therefore cannot be subjected to further algebraic treatment. This implies that we must have some other measure of dispersion. Standard deviation is such a measure of dispersion. So here limitations are, if the in a given series degree is high, then we can't find out mean deviation about the median, so they will say that those are the not exact values for the median. Because of that, they are created the next point, that is the standard deviation and the measure of the dispersion. So here next point is variance and standard deviation. Recall that while calculating mean deviation about mean or median, we took the absolute values of the deviations. The absolute values were taken to give a meaning to the mean deviation, otherwise, the deviation may cancel among themselves. Another way to overcome this difficulty, which arose due to the sign of deviations, is to take the square of all the deviations. Obviously, all the square of deviations are non-negative. Let if the given x1 up to xn be n observations, then x bar be their mean, then we have to take the square of the sums, then we will get xi minus x bar square. Next, if this sum is 0, then each xi minus x bar has to be 0. This implies there is no dispersion at all, as all observations are equal to the mean x bar. If summation of xi minus x bar square is small, this indicates that observations close to the mean. Therefore, there is a lower degree of dispersion. On the contrary, if this sum is large, there is a highest degree of dispersion of observations. Higher degree of dispersion of the observations from the mean x bar. Can we thus say that the sum xi minus x bar square is a reasonable indicator of the degree of dispersion or scatter? So let us take one examples here, that is given 6 observations are 5, 15, 25, 35, 45, 55. The mean of the observation is x bar equal to 30. The sum of square of deviations x bar for this set is 5 minus 30 square, 15 minus 30 square, 25 minus 30 square, 35 minus 30 square, 45 minus 30 square, 55 minus 30 square. So we will get sum equal to 1750, like that. Next, we can take the sum of square of the natural numbers, that is n into n plus 1, 2n plus 1 divided by 6. Here, if we consider n equal to 15, that is this formula. Next, summation of xi minus x bar square is simply our measure of dispersion or scatter about mean. We will tend to say that the set A of 6 observation has a lesser dispersion about the mean than the set B. Therefore, if even though the observation in a set A are more scattered from the mean, therefore the range of the deviation being from minus 25 to 25, then the set B where the range is minus 15 to 15. This also clears the following diagrams like this. Next, thus we can say that the sum of square of deviations from the mean is not a proper measure of dispersion. To overcome this difficulty, we take the mean of the square of the deviations, that is 1 by n into summation of xi minus x bar square. In case of the set A, we have mean 1 by 6 into 1750 equal to 291.67, and in the case B we got 80. This indicates that scatter or dispersion is more in a set A than the scatter of dispersion of the set B, which confirms which is the geometrical representation of two sets. Thus, we can take 1 by n into summation of xi minus x bar square as a quantity which leads to a proper measure of dispersion. This number, that is mean of square of the deviation from the mean, is called as the variance. Remember this definition. Mean of the square of the deviations from the mean is called the variance, and that is denoted as sigma square. Sigma square. Therefore, the variance of n observations are x1 up to xn is given, then variance equal to, remember this formula, that is sigma square equal to 1 by n into summation of xi minus x bar square. Next, by using this definition, we will define the standard deviation. In the calculation of variance, we find the unit of individual observations xi and the unit of their mean x bar are different from the variance, since variance involves the sum of squares of xi minus x bar. For this reason, the proper measure of dispersion about the mean of a set of observations is expressed as a positive square root of the variance, and that is called as standard deviation. So here standard deviation is this one, that is sigma equal to square root of 1 by n into sum of xi minus x bar square. So let us consider one example. So find the variance of the following data: 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So from the given data, we can form the following table. The mean of the calculated by the step deviation method, taking 14 as assumed mean. The number of observations are 10. So here first find out the value of this one, that is di. So that is xi minus x bar divided by 2, that is the h. Xi minus x bar divided by h, that is the width of that, sorry. So here 6 to 8, 8 to 10, 10 to 12, 12 to 14, 14 to 16, 16 to 18, 18 to 20, 20 to 22, 20 to 24. So that is width of the difference of the alternative values are 2, that is xi minus x bar divided by h. So find out value of this one, that is you will get like this. Next, by using this one, deviation from mean. So to find out this one, first we have to calculate the value of x bar. So x bar equal to assumed mean, that is small a, plus summation of di divided by n into h equal to. So here in last examples we have considered n by 2. So here we have to consider di. So next 14 plus summation of di, this, that is 5. Next divided by n, number of observations, that is 10, h, that is width, that is 2. So we will get x bar equal to 15. Therefore find out the value of xi minus x bar. Next take the square of those values. So here square is missing, so write that value, that is xi minus x bar whole square, that is minus 9 square is 81, minus 7 square is 49, minus 5 square is 25, minus 3 square is 9, minus 1 square is 1, 1 square is 1, 3 square is 9, 5 square is 25, 7 square is 49, 9 square is 81. So sum equal to 330. So we will find out the value of variance, that is 1 by n into sum of xi minus x bar square, that is 1 by 10 into 330, that equal to 33. So by using this one we can find out the value of standard deviation, that is square root of the variance. We will get 5.74. Next point is standard deviation of a discrete frequency distribution. So let us consider the discrete frequency distribution, that is xi and the fi values. So next, in this case standard deviation is root of 1 divided by capital N, that is the sum of frequencies, into sum of the fi into xi minus x bar square. So let us consider one example. Find the variance of the standard deviation for the following data. So write down xi and fi, form this table. So before that write down the formula. So n equal to fi into xi summation, that is we will get 420. So next, by using that one, first find out the value of x bar. So x bar equal to summation of fi xi divided by n. Means to find out mean, we need first column as fi into xi. So write here fi into xi. Next write the variance formula, that is sigma square equal to 1 by n into fi into xi minus x bar square. So first we need xi minus x bar. Next that's a square. Next into frequencies. So we will form this table. So first find the value of fi into xi, that value is 420. So we will get x bar equal to 14. Next take the xi minus x bar for all the terms. Next take the square of all the values. Next multiply frequencies into xi minus x bar square. So we will get this much. Next total sum equal to 1374. Therefore substitute in the variance formula, that is sigma square equal to 1 by n into summation of fi into xi minus x bar square. So that is we will get 1 by 30 into 1374, that is 45.8. Next standard deviation is square root of this variance, that is 6.77. Next point is standard deviation of a continuous frequency distribution. So here standard deviation formula is square root of 1 by n into summation of fi into xi minus x bar square. So capital N is the sum of the frequencies, x bar is the mean of the distribution of the given data. Next, here we can find out the value of standard deviation by using another method also, that is shortcut method. We will call that one as the standard deviation method. Step deviation method. So here sigma square equal to 1 by n into summation of fi into xi minus x bar square. So apply here a minus b whole square formula, a square plus b square minus 2ab. Next multiply this fi into all the terms. So fi into xi square, fi into x raised to minus 2. Next minus x bar square. Next summation of 2 times x bar into fi into xi. So after simplification we will get that value equal to 1 by n square into n into summation of fi into xi square minus summation of fi into xi whole square. So n is outside here. Here only fi into xi there. Therefore standard deviation is square root of this term, that is 1 by n into square root of capital N into summation of fi into xi square minus summation of fi into xi whole square. Here only xi square, here whole square. So consider here one example, that is calculate the mean, variance and standard deviation for the following distribution. So here given class intervals are this one. Next frequencies are. Next we have to form the table. So first write down the class. Next frequency. First find out the value of midpoint, that is 30 plus 40 divided by 2, 40 plus 50 divided by 2, 50 plus 60 divided by 2, 60 plus 70 divided by 2, 70 plus 80 divided by 2, 80 plus 90 divided by 2, 90 plus 100 divided by 2. Next multiply the frequency and this midpoint, we will get Fi into xi. Next xi minus x bar square. For that find out the value of x bar, we will get 62. Next form this column. Next Fi into xi minus x bar square, that is this method. That is variance equal to 1 by into summation of Fi into xi minus x bar square, that is 1 by 50 into 10,050, that equal to 201. So standard deviation equal to root of 201, that is 14.80. Next find the standard deviation for the following data. So here we will use the step deviation method, that is Fi xi, Fi into xi, xi square, Fi into xi square. So this value is large, so we will use the shortcut method to find out the variance and the standard deviation. That is, sometime the value of xi in a discrete distribution or a midpoint xi is different classes in a continuous distribution are large, and so the calculation of mean and variance becomes tedious to time of consuming. By using step deviation method, it is possible to simplify the procedure. Therefore, we have to consider the assumed mean as a, and the scale of reduced width is 1 by h, that is h is the width of class interval. Let us step deviation over the new values yi, that is xi minus a, this is assumed mean. Next h is the width, so that is we will get xi equal to a plus h into yi. Next x bar equal to summation of Fi into xi divided by n. Next after simplification we will get mean equal to a plus h into y bar. Next variance of the variable, that is sigma square equal to 1 by into summation of Fi into xi minus x bar square. Next here we will get h square divided by n into summation of Fi into yi minus y bar square, or you can write that one as xi minus x bar square also. Next by using that one we will find out the value of the standard deviation, that is h by n into square root of n into summation of Fi into yi square minus summation of Fi into yi whole square. So let us solve the example 11 by using the shortcut method. So calculate the mean, variance and the standard deviation for the following distribution. So class intervals, frequency distribution. So let us assume the mean equal to 65. Next here h equal to 10. So we obtain the following table. So Fi value, midpoint value. So here total observations are 7. So midpoint value is 65, width is 10. So we will form this value, that is yi equal to xi minus 65 divided by 10, that's a square. Next frequency into yi, next frequency into yi square. Next therefore we have to find out the value of variance, that is h square by n square into summation of n into summation of Fi yi square minus Fi yi whole square. So here we will get this way. H is width, n is the sum of frequencies, so 10 square divided by 50 square. Next n is 50. Next Fi yi square, that is 105 minus Fi yi whole square, that is minus 15 square. So we will get 201. Therefore standard deviation is 14.18. So in next class we will solve the exercise questions.